one of man's first scientific discoveries, friction. Its ability to make fire launched us into the era of civilization, and continues to result in the scientific nuances of today. Without friction, nothing would stop moving, and all control would be lost. Several times a day we trust our lives in the hands of friction, whether that be from preventing fatal car crashes or starting a fire to keep us warm. This property is essential to life as we know it. What is friction? Simply put, friction is the rough surfaces of objects rubbing on one another, which resist motion. There are two types of friction. Let's start with static friction. Static friction can be thought of as a grip, or when friction holds an object stationary. Static friction is used to walk or drive a car. You can think of static friction as being very fun. That is, force is less than or equal to the coefficient of static friction times the normal force. As long as this equation is true, the grip of static friction will hold until it is broken, like a box being tilted along a shelf. But how can you determine when it, breaks? The friction coefficient is a scalar, and is based on the scale of 0 to 1, with 0 being no static friction, and 1 being frictional force equal to that of the normal force. To put this into perspective, a tire on asphalt has a friction coefficient of about 0.9. Here is a demonstration involving a tire and how it can stop a lot of weight within a small surface area. I have with me a tire, some paint, and a piece of paper. I covered the tire with paint, so when it makes contact with the paper you can see exactly where it is. Now I inflated the tire a little bit to simulate the weight of a car. I'll put it down. I'm not moving this because this is only one instance in time. I lift it up. I'll do that a couple more times. And as you can see, the parts of the tire that touch the road are very small in comparison to the tire as a whole. So it's these little contact points that are responsible for keeping you in contact with the road. Thanks, Jack. Hopefully this helps you understand how strong friction can be. But when static friction is eventually broken, we now have kinetic friction. Kinetic friction applies a constant force in the opposite direction of motion, and is modeled by force equals the coefficient of kinetic friction times normal force. It is important to note that the coefficient for kinetic friction is in most cases separate from the coefficient of static friction. An example of kinetic friction being used is when sliding in baseball.
Beltre ducked off a tough hop, and the throw is wide down the line, and there we got it.
In this video, Jose Bautista slides into second base and uses kinetic friction to stop him. Unfortunately, he did not watch this video and slid in too close, making the other player a little mad. It is also important to note that friction is the transfer of kinetic to heat energy, which is caused by molecules becoming excited due to high velocity movement. This results in magma in the Earth's core and, yes, fire. With all the complicated formulas in science today, it's easy to forget the primitive history and use of science. What was a tool for survival is now used as static and kinetic friction, controlling our vehicles and melting our planet's core. Thank you for watching.